Welcome back. So we've done some practice, plenty of it actually, where they give us a diagram of a molecule and we have to figure out the name. You also have to be able to go the other way where they give you a name and you draw the molecule. So here are a few. Let's see if we can handle this. 3-methylheptane. Now, my advice to you with these is start on the far right when you get a name like this. So when I see this thing, I see blah, 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 heptane, and that is your backbone. That's your primary chain. You want to get that down first. So heptane means 7 carbons. We'll start C, C, 3, 4, 5, 6, 7. Okay, that takes care of the heptane part. Now they say on the third atom, attach a methyl group, which is a single carbon. So since I'm drawing this whole thing from scratch, I get to pick which way to number it. And of course, because I read from left to right, I'm going to go 1, 2, 3. This is the third atom, and on this we attach a methyl group, meaning a single carbon. So as far as the carbon backbone, that's it. And even this is a decent representation of 3-methylheptane. But for this question, they said, let me just confirm this off of my note, draw condensed structural formulas for each of the following compounds. So the most complicated and time-consuming way that we could possibly show this would be on every one of these carbons, attach hydrogen all around it. We know that every carbon it's capable of bonding up to 4 times, so we could take this carbon and say it's used 1 bond, it can hold 3 more hydrogens. This carbon has used up 2 of its bonds, it can hold 2 more hydrogens. Happily, they are not asking us to do this, to draw all the hydrogen fur around this thing. That would take forever and would be annoying. A condensed diagram means instead of doing that, you just write in the hydrogens next to the carbon. So this carbon is used 1 bond, it can hold 3 hydrogens. The condensed version is you write like this, CH3. This carbon has used two of its bonds, it can hold 2 hydrogens. This carbon, using 1 bond, it's got 3 left. This carbon is in the middle of a T intersection, it's using 3 bonds, so it only has 1 left. 2 bonds used, 2 left. 2 bonds used, 2 left. 2 bonds used, 2 left. And 1 bond used, 3 left. So that's a condensed diagram. Now, you can condense it a step further if you want. I'm not going to normally do this, but I will show you how to do it. You can, when you have a chain like this where it goes CH2, 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 you can cut that down so it takes up a little less space. So here's what the condensed version looks like. For the CH3, I can't do anything to shorten that up. This CH2, the same, I'm stuck writing that. Then we get CH. CH3 comes off of here. Now, the good part, I have 3 CH2s in a row, and for this you can go parentheses, CH2, 3, and then you put this, show this CH3 on the end. So that's even more condensed. And in some versions of this, to cut it down even further than that, they will bracket each of these groups. You have to be careful with brackets so they don't look like letter C's. And then they will blip out the horizontal bonds. And they'll just write that. You kind of need the vertical bonds to attach the branches, so there isn't really a good way to eliminate these. I tend to leave them in, but you might see this from time to time. I'm not going to do this condensing every single time because it's tedious to write out, and I think it's also relatively easy. So I'm going to do just the slightly condensed version here and leave it at that. If you're trying to condense one of these and you're having trouble with it, by all means contact the instructor. They will be happy to help. But let's get on with the rest of these because we have a number of them to knock off. 2,3-dimethylpentane means blah, 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 blah. Pentane, that's the important part. Start with your C's, or start with your primary, I'm sorry. 1, 2, pentane. Penta means 5. That's a little too far to the right. I'm going to run into trouble. Okay. Dimethyl. So I'm attaching 2 methyl groups. Where? On the second and third carbons. So this carbon gets a methyl group. This carbon gets a methyl group. You can go up or down with these. Technically, they shouldn't both be up because of electron pair repulsion. There should be one up, one down, if we're being a little honest, but this is already a fairly abstracted way to represent the molecules, so we're not going to worry about that too much. If you see them alternating, it's probably for legibility and because we know that these electrons and these electrons repel, so they would not normally sit side by side like this if they could help it. But anyway, that's 2,3-dimethylpentane, and all that remains now that we've got the flesh, we put on the fur. This carbon has 4 bonds, it's used 1. T intersection, 3 bonds used, only 1 left. This is only used 1, it's got 3 left. Another T intersection, this can only take 1. This is used 1, it's got 3 left. This carbon has used 2 of its 4 bonds, it has 2 left. And this is only used 1, it's got 3 left. Easy. 4-ethyl 4,6,6-trimethylnonane. Where do we start? Far right. Nonane is what we do first. Nonane means 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. On the 4th carbon, attach an ethyl group. 1, 2, 3, 4. Ethyl means 2 carbons. And now we're attaching 4,6,6-trimethyl means we're attaching 3 methyl groups. Where? On carbon number 4, on carbon number 6, and there's 2 of them on carbon number 6, so I'm going to go 1 up, 1 down. Okay, not too bad. And I'll fill in the hydrogen in case you want to watch. Going kind of fast. Every carbon has the capability to form 4 bonds. All the bonds that are not taken up by other stuff get filled in by hydrogen. This carbon is already using all 4 of its bonds. It cannot hold any hydrogen. This one is using 2. Generally, you'll find it's CH3s on the ends, CH2s in the middle of lines, and you get CHs or just Cs if you're at an intersection of some kind. This would be a 2. This one's using 4. It's all tied up, but these end caps can hold 3s. This would be a 2. 2 used, 2 left, and 1 used, 3 left. All right. 2,2,3,3 tetramethyl 4-propylheptane. So, when you see this, you should see blah, 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 heptane. That's where we start. Hept means 7. 1, 2, 3, 4, 5, 6, 7. Tetramethyl means 4 methyl groups on carbons 2, 2, 3, and 3. So carbon 2 gets a couple methyl groups. Carbon 3 gets a couple methyl groups. Carbon number 4, this one, gets a propyl group. I don't know if I can fit that in if I go up, so I'll go down. And 3 for propyl. And now we do a lot of hydrogen. This has used all 4 of its bonds, so it doesn't get any hydrogen. It couldn't hold it anyway. Ditto here, no room. CH3, CH3. T intersections, this has used 3 bonds. It only has 1 left. 2 bonds. 2 bonds used. 1 bond used. 2 bonds used. 2 bonds used. And 1 bond used. Okay, 2,2-dimethylpropane. Propane has 3 carbons. C, C, C. We're putting 2 methyl groups on carbon number 2. It would have to be carbon number 2, wouldn't it? Because if we put it on 1 or 3, it would extend the primary chain and we wouldn't have propane anymore, we'd have butane. So the only way this makes sense is if we get this cross shape. And yeah, dimethyl is all there is to this one, so now we fill in hydrogen. This is used 1 bond, 3 left. 1 bond used, 3 left. 1 bond used, and 1 bond used. And dead center, this one has used all 4 of its bonds holding on to its siblings, so there are none left for hydrogen. 4-ethyl 3,3-dimethylhexane. 1, 2, 3, 4, 5. Hexane means 6. On the 4th atom, put an ethyl group. 1, 2, 3, 4. There's your ethyl. On your third atom, put 2 methyl groups. And another hydrogen. I'm so tempted to skip the hydrogen because it's easy and time consuming. Maybe in the next one. This one's used 3. This one's used 2. This one's used 1. This is used 2. And this one is used just 1. Okay. 2,2-dimethyl-butane. Butane means 4. Now on carbon number 2, attach 2 methyl groups. And yeah, that's it for the carbon structure. This carbon's used all 4 of its bonds. CH2, CH3. Okay. Now, line structural formulae are the ones that don't show any letters. They just show lines, and the end of every line represents a carbon. However, because I'm not extremely good at doing line structural diagrams, what I'm going to do is draw the condensed without the hydrogen, and after that I will work out the line diagram from that. So you're going to see C's at first, but this isn't the finished product. We'll get to that shortly. So 3-ethyl-2,4-dimethyl hexane. Hexane means 6 carbons. 1, 2, 3, 4, 5, 6. Now, on the third carbon, put an ethyl group. Da, da. So 2 carbons attached to carbon number 3. And then on atoms 2 and 4, put methyl groups. So 1 for you and 1 for you. Now, when we're doing a line diagram, a line like this represents 2 carbons, one on the left end, one on the right end. So these 2 carbons here, I just took care of them by drawing this single line. Important to remember that. It's easy to think hexane, I must draw 6 lines. No, you're going to end up drawing 5 lines because the first line gives you 2 carbons. Now, if you're doing a hexane, this is the first line structural we've ever drawn, so I'm going to take a minute to talk about this. When you're doing 6 carbons and you draw them in a straight line like this, you don't want to do your line structural like this. 1, 2, 3, 4, 5, 6. It's a pain to read that. I mean, I did this one kind of unclear on purpose, but it's very easy for people to lose track of how many lines you've got, and it's painful to count. So, plus there's 6 lines here and there should only be 5. But you don't make them all horizontal. If you're going to do a line structural, typically you want to make the line zigzag so that it's easier for people to count your corners. So that's 2 carbons. 3, 4, 5, 6. That's how you draw hexane. Carbon there, and 2, 3, 4, 5, 6. Okay, so please zigzag them. Then, off the second carbon, we have a methyl group. There it is. Off the third carbon, we have an ethyl group. Now, I have to give this a bend, and you can go this way, or if you wanted to go that way, that would be fine also. And then on carbon number 4, 1, 2, 3, 4, we have another methyl group coming off like so. So, starting to look like a honeycomb, but that would be 3-ethyl-2,4-dimethylhexane. Fair enough. Let's see if we can fit in one more here. 5-butyl-2,5-dimethyl-decane. Oh boy. First time we've seen decane in a while, that means 10. 1, 2, 3, 4. I can go nice and small since I don't have to put hydrogen on these, and I think I'm going to have to count this again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Okay. On the 5th carbon, put a butyl group. Butyl is 4, so 1, 2, 3, 4. 5th carbon gets a 1, 2, no room to make it straight, sorry for the weird look. And on carbons 2 and 5, we put methyl groups. So carbon for you and carbon for you. All right. Now, can we do a halfway presentable structural for this? The primary here is 10 carbons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The second carbon has a methyl group on it. There. And then third, fourth, the fifth carbon has a methyl group and also a 1, 2, 3, 4. There's probably a rule as to how you bend these, and I'm not positive that this is the optimal way to draw it, but it's relatively neat. You can count your corners 1, 2, 3, 4, and that's really what we're looking for. We've got the correct number of lines coming off of the correct carbons and try to keep it as tidy and readable as you can manage. Okay, a couple more of these. 4,6-diethyl 2,3,6-trimethylnonane. So if you're drawing this, if a person's reading this to you, you're going, ignore, 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 nonane. That's the good stuff. Nonane means 9 carbons. 5, 6, 7, 8, 9. The fourth carbon has an ethyl group. The sixth carbon also has an ethyl group. The second carbon has a methyl group. So does the third, and so does the sixth. 1, 2, 3, 4, 5, 6. Okay. So if we do structural, the nonane, the primary chain is 9 carbons, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Just checking that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Okay, now the fourth carbon, 1, 2, 3, 4, has an ethyl group on it. So there's 1 extra carbon, there's 2 extra carbons. The sixth carbon also has an ethyl group on it. I could have put that going up, but this will do. And the second carbon has a methyl group. There we go. The third carbon has a methyl group. There we go. And the sixth has a methyl group. That's 1, 2, 3, 4, 5. Yeah, thought so. This one. Okay, that would about do it. And last one, I think, 4-propylheptane. Heptane means 7 carbons. 1, 2, 3, 4, 5, 6, 7. The fourth carbon, 1, 2, 3, 4, has a propyl group on it. Propane is 3 carbons, so a propyl group is 3 carbons. There we are. So for the structural, we have 7 carbons as our backbone. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. I'm a little paranoid about getting the number of lines here wrong, so bear with me as I double and triple check myself. And on the fourth carbon, 1, 2, 3, 4, we have a propyl group, so 3 more carbons. 1, 2, 3. That should do it.